Tell us your name and tell us about your project.
My name is Chad Jarnigan, and I was involved with Edwin Hubble's Galactic observations, which is also known as the Hubble telescope. Before the Hubble telescope, we had pictures of the stars and distant galaxies, but they were blurry. And the further away the object was that we were trying to take a picture of, the blurrier it got. And we wanted to fix this.
What were you guys trying to do or find?
We were wanting to take pictures of universes and galaxies that have not been explored, probably won't be explored for years and years and years due to limits on space travel. And also we wanted to finally get clear pictures of the objects in the distance.
Where did the project or experiment occur?
The telescope itself is in space about 353 miles above the Earth's surface. And while the telescope is in space, all of the construction and development stuff obviously took place down here. Specifically, at the Marshall Space Flight Center in Huntsville, Alabama, they constructed the design, all the different parts, and how to piece together the telescope itself and all of the support systems needed to keep the telescope functioning. The Goddard Space Flight Center in Greenbelt, Maryland took care of the design, development, and construction for the scientific instruments and the other materials needed to get the telescope into space. Then the actual launch of the telescope, which was aboard the Space Shuttle Discovery, happened at the Kennedy Space Center in Titusville, Florida.
What other significant events were happening around the world at that time?
The other events that happened around this time, which was 1990, the Cold War between the United States and Russia ended. The Persian Gulf War started when Iraqi militants invaded Kuwait, seizing petroleum reserves. South Africa freed Nelson Mandela from his nearly 30-year imprisonment. And East and West Germany were reunited for the first time since World War II.
Who else was involved in the project?
There were a couple people, and I'm going to kind of keep it general due to different agencies and stuff. One specific person, though, was Lyman Spitzer Jr., and he kind of got the ball rolling on the idea of having a orbiting observatory used to observe or take pictures of the distant stars and stuff. He wrote a paper in 1946, and it took nearly 45 years for his dream to become a reality. Also, there was NASA, who they provided the manpower and the rocket power in the project. And then finally, modern day, there are many people involved in keeping the telescope up to date, making sure it's functioning right, basically keeping it working, because when they first envisioned this, the telescope was not going to be used this long.
What was your role in the project?
I helped craft and shine and make all of the mirrors that are used to to diffract the light and capture the light in the form of the pictures. And I also helped prepare the parts for their trip into space.
What impact did your project have on the physics community?
Well, it changed the way we look at outer space completely. There were enormous leaps in the astronomical in astronomy, and they we were able to finally take pictures of planets and stars and galaxies with the type of definition, high definition, that we would think of today. And we were able to see actually that there were fuzzy patches of light in these pictures that no one could tell what it was, but when we took a picture with the telescope, we were actually able to figure out that they are other galaxies.
What troubles or difficulties did you encounter with getting the telescope into orbit and to function?
Well, a few weeks before the original scheduled launch for the Hubble telescope, the Challenger space shuttle exploded just seconds after its launch, which halted plans for the launch of the telescope for nearly 2 years. And finally, on April 24th, 1990, we were able to launch it into space. When the telescope was finally assembled, the pictures were not as clear as originally predicted. And what we figured out was there was a slight flaw in the way that the main lens fit, causing the light to diffract at a different way than we had planned. So we had to make additional mirrors and angle them in such a way that it was able to capture the way we wanted and get the crystal clear images that we know. And now we are able to get clear pictures of the cosmos.